Okay, 3-6, we talk about problem solving. So let's start with some problem here. Suppose I want to make a profit of $35 selling apples. It cost me $20 to rent and set up my stand at the market. What value should I set for the price? Well, okay. When we're talking about profit, you can think of profit often as the sales price minus the cost. So let's put just a single letter, P equals S minus C. So if that's the case, let's see, what do I have up here in my relationship? Okay, I know that I want to make a profit of $35, and I have costs of $20. So therefore, I want to solve for S. Okay? So let's do our algebra here. I'm going to add C to both sides. Gets rid of the C over here. So now I have sales equals profit plus cost. And I'll just plug in these values. For P is $35, and for C is $20. So I need to sell my apples for $55 if I want to make a profit of $35. Okay, here's another one. If you add 12 to twice a number and get 6, then what is your number? So what are we looking for here? Looking like we're trying to solve for our number. Let's just call it n. So we're going to add 12 to this, but not just this. We're adding 12 to 2 times this. So 12 plus 2n. And when we do that, we end up with 6. So as we look here at our equation, we have one unknown and one equation. We can solve this. So for what I need to do, what I'd like to do is let's isolate this n in particular, n on one side. Let's leave it on the left side. So I'm going to take minus 12. I'm going to add minus 12 to both sides to get rid of this 12. Okay, so now I have 2n equals minus 6. Now I have to do this. I have to get rid of this 2. I can do that by dividing both sides by 2, not 3. Okay, so 2 over 2 is 1. That leaves us with n. N equals 6 minus 2 is 3. We've got a negative divided by a positive. That means it's going to be a negative 3. Okay, that's it. Of course, if we're doing a test, I probably want to check this. So let's check by putting back in our original equation. 12 plus 2 times n equals 6. Let's stick in here minus 3. See what we get. 12. 2 times 3 is 6. Positive times negative is negative. So minus 6 equals 6. And that actually does equal 6. So, okay. See, it doesn't take you that long to check your answer. And checking your answer is a good thing to always do. Okay, here's the next problem. Let's find two consecutive even integers whose sum is 34. So what do we got here? We got two integers. Here's our first one, and here's our second one. So if we add these together, a plus b equals 34. You might want to pause this video, see if you can solve these, come up with a solution for these yourself. But if you didn't, here's what I would do then. Okay, so we got a plus b equals 34. Well, we can't really solve for a plus b equals 34. We can't solve for a or b because it'll only be terms in terms of one or the other. So I've got to come up with another idea here to help us out. And so the sum of these two integers is 34. That's one idea, but there's a second idea in here. And it says they're two consecutive even integers. So how could I write that? Well, all right, if I write this as x for a, and then b, if it's going to be an even integer, that means it's not going to be the very next. If I start out with the first integer is even, if I know this is even, then if I add 1 to this, I'm going to get an odd number. But if I add 2 to it, that's the very next even integer. So whatever I put in here, if I add 2 to it, I will also get an even. So I had to kind of think about that and come up with something that worked. And all that, when I add these two together, so this is the first number. So a equals x, b equals x plus 2. All right, so we end up with 2x plus 2 equals 34. So now it's just time to solve this relationship. Again, we'll subtract 2 here, minus 2. That kills that 2 over there. This equals 32 and 2x. All right, next I want to isolate x here. So I'll divide by 2 and 2. So 16 equals x. So am I done? No, I'm not done yet. Our first integer, a, equals 16. That means our second integer, b, equals x plus 2 equals 18. Okay, so now let's check. I'm going to do a check. Put the check here, a little balloon. I'm checking. First thing I'm going to check are these consecutive even integers. That's part of the question. Two consecutive even integers. Yeah. 16 occurs just before 18, so that's good. So now, if I add these up, 16 plus 18 equals 34. Well, yeah, that's true. 34 equals 34. So it looks like I got that one right too. Okay, here's our next question. A car gets 16 miles per gallon of gas and can travel 336 miles on one tank of gas. So how many gallons are in the full tank? So how big is the car's gas tank? So what are we doing here? Well, what we're doing is, so you might want to pause the video, see if you can't solve this. And if you didn't pause and you just stayed here with me, here's how I might look at this. We're gonna look at 336 miles. That's how far we travel. And we're going to convert this into, let's say, X gallons of gas. Notice I'm not making an equal sign here. I'm saying I'm going to convert 336 miles into X gallons of gas. Well, not only can we use the algebra techniques we learned for numbers and variables, we can also use it for units. Let me show you how that might happen here. So we know that we have 336 miles. Now I like to think of it this way. What you could do here, when you get used to this, you won't need these lines, but you could separate this up into a something like this. So this is kind of like 336 miles, essentially over 1. It's like a fraction. 336 over 1 is still 336 miles. You can think of it. Now, I want to go from miles to gallons. Well, in my car, I can go 16 miles per gallon of gas, per essentially 1 gallon of gas. I got that from here, 16 miles per gallon. 16. Now the reason the 16 I put here in the denominator is because I want to cancel out this mile. Okay? So then the relationship we're going to solve is 336 divided by 16, and the result we get is gallons. And I used scientific calculator here in Windows. 336 divided by 16 equals 21. So this one might seem kind of confusing initially, but it turned out to be a pretty simple problem to solve once you think about it a little. Okay, here's our question. A dispatcher must deliver 75,000 condensers. He has 2 truck types to choose from. The first type can carry 15,000. This is obviously the cheapest option because the second type can only carry 12,000. But union rules require that the dispatcher uses at most 2 big trucks on any job. So how many of each type of truck should the dispatcher use? Well, we're going to have to set up an equation here. We need to move 75,000 condensers, and we need to do this with big trucks and small trucks. So we know that big trucks move 15,000 and small trucks move 12,000. So if I take the number of small trucks, I multiply by 12,000. I take the number of big trucks, I multiply by 15,000. This is a B, not an 8. Then I can figure out how many trucks I use. Okay, well, again, we've got 2 different variables here. We can't solve this equation, so we've got to come up with a way to get rid of one of these variables. And the way to do that, if you want to pause and try to figure this out yourself, go ahead. The way to do that is we see that the maximum I can use 2 big trucks. So if I were to use 2 big trucks on this, that would be 30,000, which is less than 75,000. So since that's the maximum I can use, I may as well just stick that number in there and know I'm going to use 2 big trucks. So the problem then is to solve for S, the small number of trucks, given this now more simplified relationship. And we can do that. Now, unfortunately, I don't have time to work this equation out, so you'll have to do that on your own. And if you do, you should get S equals 3.75, or 3.75 small trucks. The thing is you can't have a 0.75 of a truck. So really what you're going to use is you're going to use 2 big trucks plus 4 small trucks. So what you end up using is 4 small trucks, 2 big trucks with these proportions of condensers they can carry. And I gotta go.